Hi guys, this is Mrs. Allison. Today we are going to look at proportions. So let's get started. A proportion. A proportion is an equation that states that two ratios are equal. So a proportion is an equation, which means it's got an equal sign, that states two ratios are equal. But before we go on, we should really define what ratios are. Anybody know? Ratios are a comparison of two numbers or quantities. We usually in Algebra 1 will write it as a fraction. But you've also seen ratios written with the colon as well. So sometimes you can see it written that way. But for our purposes in Algebra 1, we are going to use a fraction. So a proportion is two ratios that are equal, so two fractions that are equal. So I have some examples below that I would like to look at. We're going to look at this first one together, and we're going to look at it two different ways. The first method that we're going to use is called cross products. So I'm just going to write one. Cross products. Probably this is what you will use the most when dealing with proportions. And the idea of cross products is product is the answer to a multiplication problem. So they are multiplication problems that are cross from one another. So the first multiplication problem that we have is 7 times 12. And the cross products says that it's going to be equal to the ones that go across the 8 times the m. Okay, so our cross products say that we get 84 equals 8m. And then we solve it like we would an algebra problem. We're going to use inverse operations. So I would divide both sides by 8, and we get m equals 10.5. You will find that there are many decimals or fractions when we're dealing with proportions. So if I wanted to write this in fraction form, I know 84 over 8, 2 goes into both of them. Actually, 4 probably goes into both of them. 4 goes into 84 21 times, and 4 goes into 8 2 times. So my fraction would be 21 over 2 or 10.5. Either one is acceptable. Now, another method that we could use is just the idea of inverse operations like we've been doing with all of our equations lately. So we could certainly use inverse operations. I'm just going to abbreviate it inverse ops. And the way we would do that is when we look at this proportion, 7 over 8 equals m over 12, we know that my goal is to get the m by itself. And to undo the divided by 12 or the m over 12, we would multiply both sides by 12. So if I were using inverse operations, I would multiply both sides by 12 or 12 over 1. If you need that visual reminder, because then that on the right-hand side, we would get just m. And on the left-hand side, what would happen is we would multiply the fractions straight across. The 12 times the 7, and 12 times 7 is 84, over 1 times 8, which is 8. And then we could reduce that to be the 21 over 2, or the 10.5. But either way, we get the same thing. So I would like you to try one. Hit pause and try this example over here that says 3 over 5 equals 13 over x. Try this problem. All right, hopefully you all had a chance to try the next problem. And if we're using our cross products, we are going to multiply the 3 times the x And we're going to set that equal to the cross of that, which is the 5 times the 13. You'll notice on this one it wouldn't work very well to use inverse operations because the x is in the denominator to begin with. So we get 3x equals 5 times 13, which gives us 65. And then I'm going to divide both sides by 3 to undo the 3 from the x. And when I divide both sides by 3, I get x equals 65 over 3, or as a decimal approximation, 21.67. How'd you do? Okay, let's look at some that are a little more fun. So we are still going to use the idea of cross products, but this time we have a little more baggage that we need to deal with. We notice that both of our numerators have more than just a number or just a variable. In fact, we have an expression. But the idea is still the same. We're still going to use cross products. So I'm still going to multiply these two that are across from each other. Okay? Now the key to that is when I multiply them, I need to multiply the 4 by the entire side of y minus 8. So we're going to include parentheses. And that's still going to equal, and then we're going to multiply the cross of that. And what that looks like is I need to multiply 5 by the entire side of y plus 3. So what do I need to do now? Well, now I need to use the distributive property. And so in the distributive property here, I would get 4 times y minus 4 times 8 equals, and we're going to do the distributive property on the other side, 5 times y plus 5 times 3. So simplifying, we get 4y minus 32 equals 5y plus 15. Now I like to keep my variables positive, so I'm going to subtract 4y from both sides. If you need that visual, draw that in to remind yourself what you do to one side, you have to do to the other. So we get negative 32. Please be very careful that if there's a sign, that needs to stay with the number it's in front of. So that negative 32 needs to stay with the negative, or with the 32, equals 1y plus 15. Now using inverse operations, I'm going to undo the 15 to give me y equals negative 47. Okay. And we could check our work on these just by plugging it in. So try this next example. Hit pause and see how you do. All right, hopefully you had a chance to go through and try this. And I'm going to solve this using cross products again. So this time I'm going to multiply the 6 times the z. The good news is that is the whole side, so I don't need parentheses for that one. But in the cross product, the next side, I will have 5 times 2z plus 4. That one I do need parentheses for. Now we're going to use the distributive property on the one side with the 5 and the 2z plus 4. So let's go through and do that. So we get 6z equals 10z plus 20. We get that by multiplying 5 times 2z and 5 times 4. And again, this one I normally like to keep my variables positive, but if I do that this time, the problem is everything ends up on one side. So I think on this one, I'm actually going to have to make my variables negative and choose to move my 10z. So I'm going to move my 10z over to the other side. And we get negative 4z equals positive 20. And I'm going to undo the number from the z. So I'm going to divide by negative 4 to undo the negative 4. So we get z equals negative 5. So let's just do a quick check. Since we haven't checked any of our other ones, let's just check and make sure that we got this right. Since you all tried this on your own, this would be a good habit to do. So if I plug in -5 every place that there was a variable, so we get -5/5 equals 2 times -5 plus 4/6. Order of operations says we treat this numerator like it has parentheses, even though it doesn't. So I'm going to do -5/5 equals -10 plus 4/6. -5/5 is -1. -10 plus 4 is -6/6, and then I get -1 equals -1. So I know for a fact that z equals -5 is my solution. Okay, let's keep going. All right, now we're going to look at applications that use proportions. These come up actually quite frequently on the SAT, ACT proportional values. So let's look at a couple examples, some common ones. This first one says a portable media player, like an iPod, I guess, has 2 gigabytes of storage and can hold 500 songs. A similar but larger media player has 80 gigs of storage. About how many songs can the larger media player hold? Now, one of the things is when we're setting up a proportion, we need to make sure that like units are in the same place. Okay, so I'm going to write that down and then I'll explain what I mean by that. So we want like units in the same relative position, and I'll show you what that means. Okay, so for this particular problem, we have one thing that is for sure. It is not changing. We know all the information about it, and that is that a portable media player that has 2 gigs of storage can hold 500 songs. This is going to be our first ratio. Now, it does not matter how we choose to set the first ratio up. So if we're going to choose to do 2 gigabytes compared to 500 songs, that's fine. Just keep it that way. If you would like to set it up the other way, you can do that too. So if you would like to set up 500 songs for 2 gigabytes, that works as well. So let's look at what I mean by this idea that like units are in the same relative position. Okay, so now we need to look at the second half of this. The second half of this statement says a similar but larger media player has 80 gigs of storage. How many songs? Meaning we don't know how many songs that one holds. So if I'm going to set this up, whoops, that was meant to be a pencil. If I'm going to set this up, my ratio for that second half, I need the like units together. So if I have 80 gigs of storage, that needs to go in the top because the 80 or the 2 gigabytes is in the numerator on this first ratio. And then when it says how many songs, I don't know how many songs, so I'm going to call that X. So X number of songs. Now, you can see what I mean. It doesn't really matter how we set up the first one, as long as I set up the second ratio correctly. So for the second ratio on this other example, I would set up songs on the top. So I would have X number of songs compared to the 80 gigs of storage. Do you see how the like units are in the same relative position? It doesn't matter which proportion you set up to begin with. It doesn't matter, because here's what you'll notice. When I go through to solve this and I do my cross products on this top equation that was 2 gigabytes over 500 songs equals 80 gigabytes over X songs, we would get 2X equals, we'll do the cross, would be 80 times 500. Okay, so look at the cross product on the next one. I would get 500 times 80 equals 2 times x. Let's write it in the same notation I wrote before. Do you see that these two cross products are the same? Sure, they're on different sides of the equal sign, but they are still equivalent. So now I can go through and solve. 2x equals 40,000, which means when I divide by 2, x would be 20,000. So let's go back to the units. Remember, x represents songs. So this would be that media player could hold 20,000 songs. Okay, here's another example of where we use proportions. You've probably seen this in science, actually maybe even in math. This says how many feet per minute is 60 miles per hour. Okay, this key phrase per, we've talked about this before. Remember, per is like, we deal with it when we write in a division sign, we can write it. So how many feet per minute? So the first question says, how many feet per minute is means equals 60 miles per hour. Okay, so we're trying to figure out two things. Now, these are two different things, so we're actually going to set this up a little bit different than a traditional proportion where it's an equal sign. What we're going to end up doing is using like units to change these miles per hour to become feet per minute. So the first conversion that we want to do, let's change hours to minutes. So let's go from hours to minutes. I'm going to multiply this by 1 hour equals 60 minutes. Do you see how this ratio is equivalent? 1 hour is 60 minutes. But what you will notice is that my units will cancel each other out. And so for this, I would get, we're trying to figure out, oops, I want to go back to blue. We're trying to figure out feet per minute. And right now I have 60 miles over 60 minutes. Now probably I could reduce that, but let's keep going because right now I have the minute part. I'm looking now for the feet. So I'm going to convert this one where I put the miles on the bottom and the feet. Hopefully you know how many feet are in a mile since we live in the Mile High City. So we have 5,280 feet. And now I can do my math to simplify this. And 60 over 60 is 1, so I get 5,280 feet per minute, which is what I was looking for, equals 60 miles per hour. So unit conversions is also another place where we use the idea of proportions and ratios. Okay, let's try one more type of problem. All right, probably one of the more useful types of proportions that we will see deal with percents. Okay, and when we deal with percents, we will often talk about something like looks like this. I'm going to write it. It's going to look a little complicated, and I'm going to try to simplify it for you. A is P percent of B. When we write that, that is a common phrase that is used in math, and it would look something like this. It would say A over B equals P over 100. That's how we find percents. Now, I find that a little bit convoluted, so I like to use this proportion instead. Same proportion, it's just going to have some slightly more descriptive, I feel, words that go with this. I like to use the proportion is over of equals percent over 100. The reason I like this is because this allows me to solve any type of percent problem. And so here's what that looks like. The word is, we're going to look for several things. We're going to look for the word is in our problem. We're going to look for the word of in our problem. And we're going to look for the percent in our problem. 100 stays 100 every time. So here's an example. This first one says, what percent of 56 is 42? So I'm going to go through and I'm going to highlight. I'm going to start with the word is. It says is 42. Okay. Then I see that it says of 56. And then it says what percent? So when I set this up, this means I don't know the percent. I do know the of 56 and is 42. So this problem gets set up like this. I have 42 over 56 equals the percent I don't know over 100. Here is my is 42, my of 56, and what percent x over 100. You guys, now it becomes a proportion problem. And when I go through and solve this and do my cross product, I would get 42 times 100 equals 56 times x. And when I do 4,200 divided by 50, well, let's slow down here. 4,200 equals 56x. To solve, I'll get x by itself by dividing by 56. And we get x equals 75. So what that says is, for this problem, is 42 is 75% of 56. Okay, so that's using is over of. Let's try it on this next one. Okay, reading this next problem, it says 125% of what number is 17.5? So let's start with the is. Is 17.5. We've got that. Of. This time it says of what number, meaning we don't know the of, meaning this is going to be my variable. And then my percent is 125%. So let's set up the proportion. My is part says 17.5. My of part is the variable. My percent is 125 over 100. Okay, and now we can do our cross products. So we have 17.5 times 100 equals 125 times x. Okay, so we get 17.5 times 100 is 1,750 equals 125x. And now I can divide by 125. And we get 14. And so my statement would say 17.5 is 125% of 14. Does it make sense that it's a smaller number than what we were finding? Yes, because we're finding a percent that's more than 100. All right, hit pause and see if you can set up the last one. All right, hopefully you went through and thought about what it says. This one says what is. Then it says of 125 and then 32%. Okay, so if I set up my proportion, I would do what is, meaning I don't know this part. What is, and then the of is 125, and the percent is 32, and over 100. How'd you do with the setup? All right, if you didn't get that far, at least try hitting pause now and see if you can solve the rest. All right, your cross products should look like 100 times x equals 125 times 32. And we get 100x equals 4,000. And now I'm going to divide by 100. and we get x equals 40. So we could say 40 is 32% of 125. Now, most of your percentages won't work out quite as smoothly. There will be a lot of decimal answers, and that's okay. So if you need to hit pause or rewind this video, watch it again, that's great. Otherwise, we will see you guys tomorrow, and you have a Math Excel assignment that goes with this. Have a good day.